Hi guys, so welcome to my YouTube channel. So today we solve the problem of longest consecutive path in binary tree, right? The problem is given the root of binary tree, find the length of the longest path consecutive of the connected nodes such that each next node has value exactly one greater than its parents. That's fine. The path must move from parent to child. Only the follow increasing consecutive values. If no, then return -1. That's fine. Now I just give you the example. Like there is the 4, 1, 2, 3, right? And in that, I just have to see 1 and the 2. That there is a gap of 1. Then and there so longest sequence is 1 and 2. Okay, that is the fine. Now I just explain the problem. I just explain the problem. The problem is basically we just have to found from uh, root to child, root to always child with the exactly, that means one value greater, right? So what we can do here and what we have to use here, so we can use here the first thing is just take and go deep, just take and go deep, which means DFS, depth first search. While traversing the tree, maintain the length of the current consecutive path. That's fine. For every child, if child data is equal to parent data plus 1, which means the child data is equal to parent data plus 1, which means greater than of this, then extend the current sequence. We just have to extend the current sequence, otherwise start a new sequence, right, from the child with the length of 1. Got it? Keep track of the maximum length found anywhere in the tree. That's the simple one. So in that we just explain and just write the code about this, then you will understand what I am saying. So this is the public one, and in that public I just write the if root is equal to null ptr, right, then return -1. Got it? Now max length is equal to 1 and dfs of root and null ptr and 0. Got it? Now return max length then is equal to 2 and max length -1. Simple one. Got it? Now I just write this function of dfs. Take the private first, and in that private int max length, got it, and void dfs under that node parent int. Got it? We are going to take int current length. Got it? Now there is root base test is null ptr, then just return, and it extend if parent is not equal to null ptr and node data is equal to parent data plus 1, then current length plus plus, else the simple one current length is equal to 1, right, and then max length is equal to std. We can take, otherwise just we have to take the max of max length, right, and current length. Got it? And at the end we just write the dfs of, right, dfs of node ka left node and current length. got it? And DFS of node ka right node and then current length, simple. Okay, now just try and just compile it. It will compile successfully or not? No. So the error is root was not declared. Okay, the root was not declared. The problem is root is not declared. This is not root, this is the node. Got it? Now okay, fine, try to run it and submit it. So yes, it will submit it. So here the time complexity is, you can see there is order of n. Why? Because every node is visited at a single time, and the space is order of h for the recursion, right? So this is, so hope you will understand. So thank you so much guys.